Hey, Jonathan here. I'm going to show you today how to build this cute little radar widget in Flutter. And as you can see, it shows the location of other agents or players on the map, and it rotates according to the device location. I have the Android emulator open, and when I'm changing the compass heading, you can see that it shows where I'm heading and where the other players are. So let's get to it. So we're going to start from an empty VS Code window. Just create a new project from the command line, Flutter create. Give it the organization, just something, com.mydomain. You can give it whatever app domain you want, and this is the name of the app, Flutter Radar. And I'm gonna wait for this to create a new project, and after it does, I'm gonna open the folder in VS Code. So that was Flutter Radar. Select folder, and this is just an empty Flutter test project. And I always like to start by running the thing. Create a launch.json file, .flutter. That creates the default, and then you have the play button up the top here, so you can run and debug on this on the Android emulator that's already open. Just want to test that everything is running before we start making changes. Okay, so now we have the default app running. Doesn't do anything, but now we have a working emulator environment, and we can get going. So Flutter pub add, and I'm going to use smooth compass for this. This is this seems to solve a little performance issue that the regular Flutter compass package has. So I'm just going to use that one, which seems to work well enough. It's pretty smooth, as the name suggests, and we're going to go to the main Dart, and this just has the demo stuff. So let's create a new file, radar display, I'm going to call it. So that's the main blue radar component we're going to see. And I'm just going to cut all the boilerplate classes from the main Dart, and I'm going to put them in here just as a placeholder to use, so that I can riff off. Yeah, widgets, whatever. I'm gonna change this to radar display, and this conveniently changes the state classes as well. Let's delete all of this. So let's continue deleting everything from the example we don't need. And probably missing an import of the material here, because it should recognize the scaffold. No need for an app bar actually for this app. And I'm just going to replace the body with a simple container that basically now we're just gonna see that the background works. Let's start real simple. So we need a decoration, and we're gonna give it a gradient decoration, not this. gradient. So we want a linear gradient that starts from top center. What is it? Alignment top center. Goes all the way down. This is begin. Goes all the way down to alignment bottom center. And it has the colors of gave it blue gray or something, blue gray, and let's separate these so it's nice and tidy. Colors, let's say light blue. And here in the main, back to the main screen, we're just gonna switch the name. Radar display. No title needed. Import radar display. Null can't be assigned. Okay, let's need to delete the title from the example stuff. Can remove the widgets import, and let's see if it runs. Great, so it's running. Now I'm gonna fix the colors a little bit. Maybe just make this a little more dark. See how it looks. Okay, great. And now I want this specific widget to be full screen. So that's the next thing we're gonna do. So in the init state method, init state, we have the system Chrome set enabled. Okay, let's import it. System UI mode, we're gonna make it immersive, and that will remove the bottom part. I think we need to hot reload for this, hot restart, excuse me. Yeah. Okay, so now we have a nice full screen background. Okay, so now we want to create the nice round grid component as a background for the compass and the markers display. So for this I'm going to use an image from an image I already have, which is grid tile. It's basically like 2 lines, and I'm gonna put it on repeat, and I'm gonna overlay this thing on top. That's gonna give us the effect we want. So for this we're gonna add a folder, assets, images. I'll shift R to open it. Gonna drag the radar lines in the grid tile. And gonna go to pub spec and add the assets. Let's look. I think we already have a line for this. Yeah, assets. So this is the folder we just added. I'm gonna add all the images using this wildcard. And I think we need to stop and start for the assets to load. And in the meantime, I'm gonna give this container child. We're gonna do it with a stack. I'm gonna overlay these two images on top of each other and use a shader mask. So the first one will be the grid tile. And this is an empty container. I'm going to use the decoration again, but this time with the image. Decoration image. I'm going to give it the asset image we just added. A little bit of commas here to separate all of this. Save. Let's see what it shows. Okay, so that's the one grid tile. Now we want to put it on repeat. That's why we used the box decoration. So we can use image repeat. Repeat because I'm in the wrong place. Okay, now it's repeating. Well, let's scale it down a little bit. Scale by 2, see how it looks like. Maybe 3. Yeah, that's better. Now we're gonna dim it by half with opacity. It's looking good. Now we want to blur the edges of it, the edges in a circular shader. So what we're gonna do is I'm gonna click fast quick actions here and wrap with widget. This is a convenient way of wrapping a child widget. So shader mask, and now we need to give it a shader callback. And I'm gonna return a radial gradient, which is gonna give us the effect we want. So the colors would be from white, which is not shading anything, to transparent, which is transparent. Now we need to tell the gradient to create a shader with the bounds here. And let's see how this looks like. Yeah, so as you can see, it's starting off by showing everything because it's white, and then going all the way to transparent. And gonna mess around with this a little bit, a few more parameters. The radius might be a bit smaller. And now I want to make it a little brighter in the middle. So I'm going to add the stops field, which has to be the same length as the colors. So I want the white to start not from 0, so it won't be a uniform gradient, but start from 0.3. And then I want the transparent to hit a little more steeply. So I'm going to give it 0.7. This just creates the more steeper gradient. So now that we have our grid, we can add on top of it as another child of the stack the asset image that we added of the circular radar lines. Image.asset, this is the asset path, radar lines, PNG. Let's see what this looks like. Okay, so it's not centered. We can use the quick actions to wrap with center. So this is starting to look like the baseline of the component. And maybe let's give it all a size limitation. Wrap with widget. Actually wrap with sized box. Then we can give it height and width. This is just for testing purposes. If you want to later use this in a context of a larger app, you can make this a parameter. So yeah, this is because it's not centered. I'm gonna wrap it with the center. And now it looks a little tighter. So let us now add the icon at the bottom right here that shows the direction of the compass. I'm gonna use the image compass.png, but you can use an icon or whatever. I'm gonna wrap this with the column because it has children and change to stack. And just minimize this and add an image.asset here. Assets, images. Great, so this is showing now on top but at the wrong place. So let's just wrap it with a container. It has an alignment. Bottom right. And side commas. And let's give it a little bit of margin. Great, it's a little too big. So let's scale it down by 2. That looks good. So now we're going to create the center arc that shows the direction. This one always points up. So as everything else rotates, this arc will will always give an indication of where I'm heading. And for this we will need to use a custom painter, and we'll put it in the inner stack. So let's start with a container, and I'll extract this widget and call it direction arc. And I'm going to put it in a new file. And use the quick actions to import it. And now I need to add a custom painter. And we can give it a size later. And now we need to define this class, create class, and this will extend custom painter, which will allow us to basically paint whatever we want on the screen. 2 missing overrides. Paint and should repaint. So should repaint, this can basically return false, and this is the interesting function. So let's define our paint. So this is full alpha, and I don't know, that should give it some color, and we can then change it to some sort of blue. It wants to be const. Now on our canvas we're going to use the draw arc function, which has a rect. And the center has an offset of the height and width of the canvas. Now we have to also add the height and width. Size height, width, size width. And let's close a few windows. Okay, so now we have left to add the start angle and end angle. So this is in radians, so I'm gonna write the relevant angles here. times math pi divided by 180. This is the way to convert from angles to radians, and this is one import that doesn't happen automatically. Okay, and now the sweep angle will be 90. So that's how long the arc will be. And we're going to use the center, and we're going to use the paint that we just created. And let's see how this looks like. It doesn't look like anything. Why is that? So this is probably missing the size parameter. Let's see if this helps. Yeah, okay, so now we see the arc, it's got the correct shape. Now the size parameter really should be a configuration sent from the outside. So let's add a named parameter, and final double size, and let's give it a default value. Let's move this out into the class, and now we can use this size wherever we need the size. And let's see if this works. Change the size to 100. This also needs to be in the center. Const, okay. Center, const. Great, so this is starting to look good. And let's also give it the color parameter, which makes sense to be configurable. Color, this color, add the name parameter. This, and I'm going to define a field, and inject it into here. And of course we can't use it because it's in a different class, so we need a constructor here as well. Final color, and my painter constructor that gets color. This needs the brackets. So now we can use it within the class, and we need to send it here. Okay, it didn't change, so it's still working. This is a better design. And now the only thing remaining is to give it another radial gradient to make it fade out a little bit as it goes out from the center. So let's go into the build function and wrap this thing with a widget. I'm just gonna copy what we did here. And let's see how this looks like. So this looks a little weird because the transparent is making it grayish black. Need to keep it on the white spectrum, and this actually looks pretty good. So I guess we can extract these two parameters, but not really important for now. This is good enough. And now we can go ahead and add the smooth compass listener and finally start rotating things according to the compass direction. So we need to return the smooth compass here, smooth compass component, which we're gonna import from the package. And this thing accepts the compass builder. Which returns the container that we currently have. Oops. I'm just gonna add the closing parentheses here and see if it compiles. Excellent. So now what we basically have is a builder that sends us the compass data, which is an async snapshot that contains the data, which includes the angle and the turns that we need to do. So let's try and first rotate the little arrow at the bottom according to the data. So animated rotation, because we want it smooth, right? And we have turns, so compass data conveniently contains the turns. And for some reason it's inverse, so we need to multiply by -1. So this contains the turns, and the duration, we're gonna give it something that we're probably gonna extract to a const later. 200 milliseconds for the animation, and the child, which is this. Turns. We need the data. Okay. So these are all null modifiers. Let's just so we can see that it works, check if it's null or compass data null, and give it a 0 turns, and this should be good. And now we're not seeing the icon at all because it's it's rotating the whole container, including the margins. So that means it's rotating around the edge of the screen, and it's probably down here somewhere. So what we can do is just swap with parent. So now we're only animating the actual image, and it's rotating around its own center, and that should probably solve it. Okay, so now we have this slight angle here, and in order to see that it changes when we change the heading, let's open the emulator settings, direction, virtual sensors, device pose, and now we have the ability to change the direction, and it's working. Excellent. Okay, so now that this bottom thing is rotating, we need to rotate the grid lines as well, and after that we can add the markers. So I'm just gonna copy this animation with the same turns and put it on. We don't want to rotate the directional arc, we don't want to rotate the entire container, of course, so we just want to rotate the inner tiles, the inner repeating tiles. So that's this container. Copy one parentheses. Let's see. Ooh, that's so weird. Let's try and swap it with its parent. That's better. Now let's test the rotation again. See how it looks like. Yep. Okay. Now we should be doing a little bit of refactoring, because we copy and pasted. Every time you copy and paste something, you need to think whether you need to do refactoring. So this whole line of code here, maybe we just need to get the turns once and use it in both places. So let's extract this and call it animation turns. We can calculate it once we have the compass data. And we can use it in the same place that we copied and pasted, which is here. Num final. We need to explicitly define it as double. Let's see if it doesn't change. Okay, great. And another little bit of refactoring is the duration. We have 200 milliseconds and 200 milliseconds. I don't see a situation where this should be different, right? So we can extract it. Let's make it a field. Create a field. It's going to be a double. 200. Let's maybe add milliseconds so as to be explicit. Double can be assigned to type int. It's an int, of course. And we're going to use the same thing here. It's no longer a const. Great. So the only thing left now is to add the pulsating markers on the map. So I'm just going to add a new container on top of the other stuff on the stack. This is just a placeholder. Basically, I'm writing this to extract it to a new widget called markers display. And I'm gonna cut it from here and paste it on a new file to keep things organized. Markers display dart. Let's use material and let's import it in the main file. And now let's go ahead and start building this component. Basically what this is going to have is a collection of markers. So for this, in a real game or app, this would come from the database. But just in order to demonstrate, I'm gonna create it statically within the widget, and I'm gonna convert it to stateful widget because I want to save these this list of markers in the state of the widget. So let's define a field called markers, and this is going to be statically initialized in the init state, and this is going to be of type list marker. And we're going to create a simple new Poco class, so plain old C object, which contains only fields, and this is just to simulate the geolocation classes, various geolocation classes you're going to use either from the database or from the location. So double latitude, double longitude, and this is all we need, and we need a constructor as well. We're gonna send it both parameters, longitude, and make these final. And finally, we can initialize this as empty, and in the init state we can go ahead and add the markers. Just for demo purposes, we're going to create a loop that randomly generates these markers. Ten is enough. So here we're initializing a new marker. And let's start with the latitude. Let's just give it demo stuff so it compiles. Okay, now it should compile and tidy it all up automatically. I'm gonna extract this to a new file as well, the markers class, to keep everything separated. So this, as we said, is a Poco object. Import. Okay, now let's give this a random random location, which is using Dart math and next double. So this gives us a random value between 0 and 1. I'm going to call this again, so it will generate another different number. And so we're going to keep this number between minus 0.5 and 0.5. And the purpose of this is to generate random markers that are around my current location. So I'm going to add another my location here, which is again to simulate my own location. And let's give it something that sounds like an actual latitude, longitude, 30 on 70. Let's add this field. And actually, let's initialize it up here. So in a real app, this would come from the location or geolocation packages that give you your own location. And now I can add this my location field to the random numbers I created. And now we have the initialization of the marker, so we have something to work with, something that we can see. So now in order to actually see something, let's change the build function to have a stack, and the children of the stack are gonna be, and I'm gonna do some calculations here. So I'm gonna start straight off by extracting this to a function, get markers, and no code suggestions. Really? Okay, create function, not outside the class, in the class. This is just a helper function to help generate the widgets that are basically a mapping of the markers here. So I'm going to return a list of widgets. From a mapping of markers. So for each item in marker, I'm going to execute a function that will return something. So what's that something? For each marker, it's I want to position the thing So position it on a stack. So we're gonna give it a left and right. Let's just do 0 for now. Left and top. Right, so that's the left and top corresponds to latitude, longitude, and the child will be a container that has a box decoration with the shape of a circle. I'm gonna give it a white color, and I'm gonna give it a box shadow. What's with this global thing? Color. White, so white again, and it has a blur radius of I think something like 10. So these values are going to be replaced by the animation. So this is what we're going to animate later, the blur and the spread. So these are both going to be the same value that comes from the animation. Add nice commas. Return positioned. And this is giving me an error probably because it's not a list. To list. Function expressions can't be named. Oh, okay. Missing parentheses, of course. Positioned. Yes, I'm not sure we need this to list because it's list.from anyway. Expected to find. Yeah, this seems to compile. So now we're seeing the position. We gave it a 0, 0 left top, and it's actually painted in the very top left of the screen. So the first thing we should do is move the markers display from the top level stack to the inner level stack, because it's a part of the radar component. Okay, so that's better. It's showing at the top left border of the radar widget. And now let's give it, of course, the latitude and longitude of the marker. Left is longitude. Yeah, longitude is the X and latitude is the Y. And let's see what happens here. Right, so still all of our markers are displayed in a very small region, and that's because the random variation is between 0 and 1, or minus 0.5 and 0.5. So we need a form of mapping to map this to more reasonable coordinates that are centered around the center of the radial component and are spread out a little bit. So 29.9, and so this is very close to the 30 and 70 that it was initialized with. And okay, so for that we're gonna add a little bit of math to compute the coordinates. And first of all, we want to find the difference between the marker latitude and my location, right? Longitude and the same for latitude. And we will create the top and left parameters, so we can send them over here. Let's so we'll need to multiply this by something later. Let's leave this for now and just see how it looks. Okay, I didn't update. Yeah, okay, so that's better because now it shows all of them centered around the beginning of the widget. So now if we have some ratio, let's say 100, and we multiply this, this should spread them out a little bit. Okay, so we can see that they're starting to spread out, and now the only thing we have left is to center them around the center. So now in order to center it, we're going to do plus 150 y 150 because that's the size of the widget divided by 2. So now it's time for a little refactoring. This is like a code smell. This is a magic number, so it's not clear where this number came from. So let's write it explicitly, divided by 2, and this again is a magic number, y 300. So let's make a parameter, and we can send the size from the, whoever uses the component can decide what's the size. We're going to simplify by creating just one size, because we're going to assume that because this is a circle, it's always going to be equal width and height. But of course you can expand this later. Final double size, and we're going to make this required. Now we can send this as the size, widget.size. Copy it. So as we can see, this is working. Oh, okay, it's not compiling because we need to send a size. So the size was 300. Now this generates a new set of markers each time because it's hot reloading and recalling the init state. And so now there's another little bit of refactoring because this 300 number is duplicating across 3 places, which is another little thing we can improve and extract this number. Put it in all the places. And as an improvement to this in general, you can later take that number from a dynamic screen sizing. It depends on where you actually want to put this component. But for simplicity, I'm just going to leave it as a static number for now. But at least it's written generically and not full of magic numbers everywhere. So the last magic number we have left is 200. So where does this come from? So this ratio, we are basically taking the diff between my location and the next player location, which in this case is gonna be max 0.5, and we are multiplying it with ratio. So in this case, if we look at the maximum, if the markers spread to the max, that means that a 0.5 diff will span across 150, or more generally a diff of 1 will equal 300. So that's basically us converting between map coordinates and screen coordinates. So if the diff between our map coordinates is the one, basically, because our random goes over a span between 0.5 and minus 0.5, which is 1, and this is divided by the size of the screen. So excuse me, the size of the screen is divided by the maximum randomness that we have on our on our demo markers. So this is the screen size, the widget screen size, and this depends only on the widget. What's wrong here? Const variable. Okay, final. So so this is the size that we are getting for our component, and we are dividing it by 1, but this is only for the demo. In real life, when you have your actual map markers, which represent real live locations, you can adjust this to whatever the radius on the map that you want to show. This is basically the zoom level of the map. So let's replace this with a parameter so it becomes more realistic with the zoom level of the map. I'm gonna add this as a parameter here. And I'm gonna send it from the outside as 1. .0. Excellent. So now we see the markers are spread out exactly to the edges of the widget, and this actually looks a little weird. So we wanna zoom out a little bit. Replace it with const, and if we're gonna zoom out a little bit, we're gonna have a zoom level of 1.5, and that's gonna bring us back to the markers being a little bit more centered. If we increase the zoom, it's gonna be even more centered. So this shows a greater span of the map. Let's leave it 1.5 for now. So now we are ready to add the pulsating animation, and we're going to start by adding a single tick animation mix-in. Might as well fix some of these warnings. And we need to initialize the animation controller first. Vsync this because this now has the single ticker provider, and duration just some duration, doesn't matter. Of course we can extract a parameter, but we can also leave it here for now. Let's add this as a field and make it nullable. And now we can also add the animation object. So it's going to begin at the radius of 2 and end at the radius of 10. It's a regular tween animation with the animation controller. We can be sure that it's not null because we just initialized it. This this is all just boilerplate code. You can basically copy and paste from the official example. And let's add a field. Okay, now we have the animation, and we have the controller. We need to add a dispose, because the dispose of the animation controller doesn't happen automatically. So here we're going to call super dispose, but before we dispose the actual widget, we're going to dispose the animation controller only if it's been initialized. And now we can go to the markers list and replace the blur radius with the animation value, of course, only if it has a value. So let's say that it's 0 in case of null. I'm gonna put the same thing here. And the only thing that is left is to start the animation by calling animation controller repeat. Let's see how this looks like. Yeah, okay, so it's going the wrong way, the wrong direction. Let's reverse it. Yeah, that's what we want. And now what's missing is to also show the center. So basically to show my own marker, my location. And we're going to do that by going to the init, the initialization of the markers, and just adding my own one. So now we should see this central one as well. Excellent. And now the only thing that's left to complete this widget is to actually rotate the markers according to the compass rotation. So we've already extracted all of these parameters, so we can feel comfortable copying and pasting it. Adding the const. Let's see if this actually rotates. Where is this? Okay. Yeah. Okay. So this is it. Everything is working. Thanks for watching so far. Hope you've enjoyed it, and catch you later.